Hello and welcome again to another Physical Sciences 3 lecture. We are continuing on with our conservation of energy examples. And so in this example here, in example 6, we have a 30 kilogram child is at the top of a 3 meter high slide, assume frictionless. What is her potential energy at the top of the slide? So our EP equals mass times gravity times height, which is equal to 30 times by 9.81 times by 3.0. And if we look at our calculator, we have 30 times 9.81 times by 3. That's equal to 883. And that's in joules. What is her EP at the bottom of the slide? So potential energy, so this time it's equal to 0. And why can I say that? It's because H is equal to 0. Okay, H is equal to 0, so that means that her potential energy is going to be equal to 0. And her increase in kinetic energy, well, her change in kinetic energy is equal to the change in potential energy, which is going to be equal to 883. Because we've gone from having 883 joules at the top of the slide of potential energy to 0 joules of potential energy, so all of that energy must have been converted into kinetic energy because we assumed that the slide is frictionless. If the girl was at rest at the top of the slide, what would her speed be when she reached the bottom? Okay, so what we can do then is EK is equal to 883 joules. So 883 is equal to half times 30, which was her mass, times velocity squared. Okay, so V squared is then going to be equal to 883 divided by 15, because 15 is half of 30. So V is equal to the square root of 883 over 15, which is then equal to, and you might see it up here, I've already done it before, 883 divided by 15, square root of that is 7.67. 7.67 meters per second. Okay. Her father, who's 85 kilograms, then rode a slide. What would his speed be at the bottom? Well, we could go through all of the same calculations again, but I can tell you right now it's going to be the same speed, and that's because mass doesn't have anything to do with the change in potential to kinetic. Okay, and we can look at that if we make EK equal to EP, so the change in kinetic energy is equal to EP, we have half mass velocity squared is equal to mass times gravity times height. So if we want to rearrange for V, which is our speed, the masses will cancel out on this side. And then we can say V squared is equal to 2GH, and V is equal to square root of 2GH. It's getting a bit small there, 2GH. So then if we put in V equal to the square root of 2 times 9.81 times by 3 in our case, we get, let's put that into our calculator, and let's have a look. So we go square root of 2 times 9.81 times by 3.0. Close that bracket off. Oops, there's no bracket. That's fine. 7.67 again. So we get 7.67 meters per second. Okay, so in the future, you should just be able to say, well, it's going to be the same since mass doesn't make a difference. Okay, it's all about acceleration due to gravity. And it's like the famous experiment, and you can look this one up on the internet, where we have a bowling ball and a feather being dropped. There's a good one with Brian Cox, so I recommend you have a look at. It's a Galilean experiment. Okay, so we'll do example 7 in the next lecture.